Hello, everyone. I'm Zhao Chuang. Today, let's talk about the reconstruction of Wyatt the Parasaurolophus. This Parasaurolophus model is a P. walkeri, which is made based on a very well-known and complete specimen. Let's first look at its head. Parasaurolophus was a typical hadrosaur with a duck-like bill. The scientists deduced the duck-like bill by the shape of its skull. Judging from its skull, its mouth did look like a duck, but when it was alive, a keratin beak protruded downward from the front of its mouth, a bit like an upturned bowl here. This kind of dinosaurs normally had a little tip at the front of its beak, but this structure was not found in the mouth of Parasaurolophus, so we relied on the beak structure of dinosaurs such as Edmontosaurus. Its large nostrils were located at the upper part of its head. This part borrowed ideas from the specimen, which shows two elongated nostrils, but they might have been covered by soft tissues when it was alive. The opening of the nostrils was closer to the front. Except for the two concave nostrils, the nose area was covered with keratins, which extended backward all the way to the iconic cranial crest of Parasaurolophus. Its crest was very long, and probably looked like a bone when it was live. There might be a keratinous sheath on the crest because it had a rough surface. This texture looked like a structure that could attach the keratin. It probably had keratins extended to the top of the skull just like its beak, but its keratins were not the same as those of ceratopsians' horns, and were simply wrapped on top. Its crest was connected to its nose. Its nostrils extended inside like this. If you look at its crest from the side, you could see a groove, which divided the crest into the upper and lower parts. Internally, it was a paperclip-like tube attached to its nose. Scientists can simulate the sounds of real dinosaurs by blowing air into a model of its head, which sounds like trombone. The air flew through the nostrils, which formed a paperclip structure, and into its lungs through the tortuous channels, producing a trombone-like honk in the process. Below the junction of its crest and head were its small eyes. Further down were its very developed masseter muscles. Although it was a herbivorous dinosaur, it had a lot of teeth in its mouth, which came with very strong oral muscles to crush all kinds of plants. Its neck was quite long, judging from the fossils. In fact, when it was alive, the neck showed an S shape wrapped in a thick layer of muscles. Some argued that its dorsal part probably were quite muscular, extending forward from its shoulders. We did not take this view when making this model, but decided to make its neck wrapped by well-developed muscles. So the neck of this model looks much thicker than people normally would shape its neck muscles. When reconstructed its neck, our main reference was a duck-billed dinosaur specimen called Leonardo, which retains the complete neck muscle structure. Moving backward, we come to the well-known feature of this Parasaurolophus specimen, the notch at its back. Early research made many claims about this notch. At first, people thought that a large number of muscles were connected to the neck from here. Some other theory claimed that because Parasaurolophus had a long crest, it would stretch its crest over to rest it in the groove when it was resting. But of course, interesting as it might be, it wasn't true. The more careful study of this specimen in recent years has shown that the notch was actually a wound, a malformation caused by a childhood injury. Other healthy Parasaurolophus might not have such a notch. We have not yet found other specimens as complete as this one, but the deformed lesion can be observed from its bone structure. For example, the neural spines in front of this notch were inclined forward, and the ones in the back were facing backward. When the anterior neural spines tilted forward, they fused with the neural spines of another bone, which was an obvious pathological phenomenon. So this notch, also a very famous feature of this specimen, was actually a demonstration of trauma. We chose to show this characteristic when we made this model. There was a row of these bulges on its back from the shoulders to the tip of its tail. At the beginning of the design, I wanted to present a healing wound here, but after further research, I thought it should be a blunt trauma, so I didn't go with that kind of wound. It may have been crushed by other dinosaurs, or hit by a fallen tree and fractured when it was young. Therefore, as it grew up, its back had a long string of spine-like structures from its shoulders to its tail. But this string structure was interrupted and missing here. Lizards with spines on their backs would also have some deformities, or dysplasia in the spot where they suffered a bruise. So this model reflects this characteristics here. The forelimbs of duck-billed dinosaurs were relatively thin, especially the lambeosaurines. However, the forelimbs of Parasaurolophus were relatively thicker, viewed from the bone. In the reconstruction in recent years, due to the preservation of a large number of mummified fossils, we now tend to believe that its forelimbs were indeed quite thick, just as this model shows. But they were still much thinner than its hind limbs, plus its claws. Many duck-billed dinosaurs probably had forelimbs like this. It had 3 functional fingers that may fuse into one giant hoof. This hoof was divided into 2 sets. One was the corresponding index finger, forming a small tip, and the other 2 fused into a larger hoof for real walking. It also had a little finger, which was not as long as we used to think, and most of it was probably buried inside with only a tiny tip exposed. It had excessively stout hind legs. Since the bones of duck-billed dinosaurs were very well preserved, we can also infer the general distribution of its muscles based on the attachment points of the muscles on the pelvis and the thighs. We can only deduce the general muscle distribution of prehistoric creatures, because each animal's muscles were overlapped in different ways or in different thicknesses. Then let's move to its feet. Parasaurolophus had typical duck-billed dinosaur feet. If you look at its sole, it's 4 pads shaped like the petals of plum blossoms. 3 of them corresponded to the 3 toes with a smaller one at the back, forming a club shape. Its toenails were very flat and hoof-like, and the hind legs were much larger than the forelimbs. It had a very thick tail. It couldn't swing it in a large arc, because there were many cross-ossified tendons on its tail. In some species, these tendons would extend to the back, forming a stiff arch structure from the back all the way to the tail that supported its entire trunk, and allowed its tail to hang in the air. Of course, its tail could also swing, but may not be in large range of motion. When swinging, these cross-ossified tendons would slide under the skin like a security door, which was a very interesting structure in dinosaurs. It could not only maintain a certain degree of flexibility, but also create a strong rigidity, allowing its body to carry a huge weight, which was also the secret why many dinosaurs were so large in size. When it was alive, its tail would be thicker than the fossils show, because there may have been some flabs under the hadrosaur's tail, which may contain fat or the like used to preserve nutrients. Then its skin. People found many hadrosaur skin fossils, most of which were with very delicate scales. Different hadrosaurs had different skin patterns. Some of them had large scales mixing up among smaller scales. When we shaped the scales on the body of a Parasaurolophus, we adopted the reconstruction method we did to most duck-billed dinosaurs. The body would be composed of small scales, and some large scales mixed among them. People found similar skin on Corythosaurus and Lambeosaurus, which were closely related to it. On the skin impression on the tail there were such rows of scales that extended all the way to the belly, which may not be able to provide much protection because the scales were so small. They may be just an ornament or give some degree of protection. On the side of the body of Saurolophus, there were also such granular bulges. So we borrowed ideas from these several duck-billed dinosaurs. There were very few Parasaurolophus skin fossils discovered, but a skin impression with fine scales was found on the foot of a young Parasaurolophus. It was unlikely that any duck-billed dinosaur would have had such large bumps on their feet. The skin of hadrosaurs also showed there weren't large keratin sheath structures, or large scales on their feet like those of birds or theropods. The front of its feet was covered with fine and smooth small scales, but may have many folds as well. We chose the brown as the overall color scheme, which is the approximate appearance of animals living on the plains. There were keratins on its crest with a prominent shape. When it was still alive, the crest can give sonorous roars, and its bright color could be used for interspecies identification. So we adopted bright colors on the head. Many duck-billed dinosaurs had a row of ornament spines on their backs like this, so we also used relatively bright color for this part on its back too. Moving downward from the bright color patches, there might be some slight stripes. These stripes were relatively simple, which looked a bit like that of modern animals such as okapis. The above is the reconstruction of Wyatt the Parasaurolophus. Thank you all.